Good evening. Thank you for taking out your precious time to attend this webinar in collaboration with PV Diagnostics. We have with us Mr. Ayush Mahajan and Mr. Atul Jain from both are the co-founders at PV Diagnostics, and they'll be taking the webinar ahead. So Mr. Atul comes from IT Bombay. He has 10 plus years of experience in diagnostic plants and iterating the malfunctions in the same. He has a 1.5 gigawatt plus of portfolio in O&M, and he'll be assisting Ayush in this webinar to take it ahead. Ayush also comes from IT Bombay, and he's having an experience of 8+ years in solar energy sector, and they've been working closely with PV Diagnostics from past 4 years plus. So Ayush and Atul, very warm welcome in this webinar, and we shall take it ahead now.
Thanks, Abhimanyu.
Yeah.
Thanks a lot, Abhimanyu, for the introduction that we see through our work. In this webinar, I'll be mostly covering about, we'll be sharing about from our experiences that we have seen from the site. So everything that we will share is, in some way is actually our on-site experience. And all of those things, will be from our on-site experiences. And I think that is the best way for, for anyone to learn or to. So so as I was saying, that we'll be majorly covering from our experiences on site at various, sites that we have visited across India. And from there, the learnings that one can have, and nothing better than, sharing those learnings with everyone, so that it can be applied on a larger basis, and if everyone can benefit. And that is why we also like to do these webinars and do a lot of knowledge sharing as well as part of PV Diagnostics. Because, as a company, we can work with so many people only. So that is why these sharings become very, very important. I think I do not know if everyone knows about PV Diagnostics, but quickly, because we don't have much time, we are already at 4:37. It's just an hour's discussion, right? So I'll just quickly give you a brief intro of PVD, so that, and then, in a couple of minutes, I'll just give you a brief intro to help everyone get a context of where observations are coming from. So we are a solar tech consultancy firm, and we have done more than 6. We do assignments from quality monitoring, diagnostics, technical due diligence, factory inspection, all kind of activities. These are few of our clients. I think doesn't matter right now. So the core team comes from IT Bombay and industry veterans. We started the company. Two of the 4 co-founders, and Mr. Prakash Suratkar and Mr. Pyranometer are not here on the call. So our expertise, lies a lot on the technology, model technology side of things. And we understand the semiconductor technology very well in detail, and that kind of helps us a lot in understanding what is happening at the plant. We combine it with automation and a lot of, automated softwares that we have developed to do analysis. And these are our broad, services like on-site diagnostics, technical due diligence, quality inspection, monitoring services, and project consulting services.
Yeah, Ayush. Yeah.
Yes.
So the presentation is on this topic, and I think one of the major drivers, major challenges in O&M is because of the O&M budget, and because of which it may lead to downgrade in O&M practices, and might lead to cutting corners and all in the solar power plants, maintenance, and which can lead to a lot of issues, and especially in India when the sector has been, the bidding has been so which is with respect to pyranometers. And what we have seen, this is for one particular site, but we have seen this at multiple times that, so pyranometer, we consider it one of the most important components of the plant. WMS, specifically pyranometers, essentially because it helps us in understanding what is the performance of the plant, the get the right PR, the right performance ratio. And it comes in because it comes in the denominator. If it is recorded wrongly, it can really impact our understanding of the plant, and us in a way that we are not able to understand where something is going wrong. So it is one of the key KPIs that needs to be understood very well. And this is one of the things that we see at site, that a lot of times, pyranometer, when you see at a site, it may be at a wrong angle compared to what meter might be at a 23-degree or a different angle, which essentially what it leads to is that it leads to a lesser radiation on it, and will lead to a wrong reporting of PR, as in if the radiations are recorded less, the PR is reported higher. That is one of the key things that we see in a lot of ways that I'll share in the next slide also. When we go to the site, we take our own pyranometer, and like when we do the comparison between the two pyranometers, we see sometimes we see drastic differences, and that is something which is really important. And a lot of times, I mean, see, this could be happening because of some general oversight, because of the lack of know-how, or this could be a small, I mean, like a manipulation thing as well. But this is something that needs to be taken care of by O&M companies or by developers to ensure that they get uh, the right numbers. Another thing that we have seen is cleaning of pyranometers. So if the cleaning of, at times what we have seen is that the cleaning of pyranometer is at the same rate as the as the model cleaning cycle, which essentially means because of soiling. So the soiling loss is not factored in, and it is very important that the so that dust doesn't doesn't get settled on it, uh, and the and the pyranometer records the right radiation throughout the life cycle. So on a daily basis, there are standard cleaning methodologies which can be followed to avoid these again report really high PR because of these lack of clarity in terms of cleaning or wrong angle of PR of pyranometer. So this is something which is really, really important. I mean, and specific, we see this all of these observations, they at the end they lead somewhere. If you are a if someone, so how it impacts is that on a long term, if someone is even looking to sell assets, the data becomes more reliable. If one finds, if a buyer is happening, then the trust on that data goes down. So it's very important to keep these things straight from the day one. uh, and if there are people who own assets for a very long time throughout the life cycle, again for them it becomes important, because they need to know the right numbers and right issues in the plant. If one knows the right PR, then you can go and address the issue. Otherwise, it's not about the point that the PR is less, but what can be done to improve it. So moving on to the next point of Pyranometer, again sharing another case study. So this is some 25-30 megawatt plant. What is happening, what was then when we installed a calibrated pyranometer with the on-site pyranometer, we found that the accuracy of the pyranometer was quite less. So if you see here, the black the chart on the left, the black line is a calibrated pyranometer, and the blue is the on-site pyranometer. So you could see that because of the fluctuation, I mean bad weather fluctuations in radiation, it actually led to showing how the inaccuracies in the pyranometer. Again, this is kind of an issue. So a lot of times what we see on site is because the pyranometers are not calibrated well, they lead to essentially it wrong recording of radiation, and again leading to a wrong PR number, a wrong radiation number for that site. The one on the right that you see, the chart on the right that you see, there is the dark blue line is for a calibrated, is for a on-site parameter. Here you see that there is an overlap. So this is again from a site only. This is not from I mean, we have not created it through some. So it is not that it can't be this kind of a situation. If it is maintained well, it can definitely be this. We can get this accurate data as well. So this is at the end of the day an O&M issue, manpower that can be there to address it, better processes. So I mean, it's not always that it's the people on the plant who's the reason. It could also be because of some not the processes not being in place. So it could be from management level to a technician level issue. It could be anything. So in India, one of the things that we have seen is the lack of trained manpower that is there for plant maintenance. We hope that it definitely increase over time, but we have seen at times that there are issues in maintenance. So this was with respect to Pyranometer. Now this is another very, very important thing. Gaps in SCADA data. So again, I mean, these things are important because at the end they help us in understanding the plant performance, and these things are such that they can be addressed very easily as well. So as a starting point, we bring data that is there from the SCADA that is available at the site, and we usually the data which is used to calculate PR. And what we saw was that on the chart on the left, if you see, it actually shows that the PR based on the data that is coming from the plant, the PR is going up to 200%. I mean, not even 90. I'm not even talking about 90. For example, the inverter is logging at every 10-minute level. The WMS, the weather monitoring system, was logging at a minute level. So because of this, when you combine the data and when you sum it up, essentially it will lead to some kind of issue if it is not analyzed properly. These kind of abnormalities are found in SCADA data that is there. The software company may write a code or make it a very high value to do something. It is basically a software level issue, and a lot of times those abnormal figures are there which should not be used in analysis. So a lot of those filtering and all is required. So in the chart on the right, you see that once the data was filtered and analyzed properly, the PR came to about throughout the day, it came to be about in the acceptable ranges. So this filtering and analysis of data is also very important. But a lot of times the issues in the SCADA itself, because the data logging and the intervals at which it is collecting is not out of, let's say if there are 10 inverters, you are getting data from 5 inverters, not getting data from 5 inverters. Now if I compare all of these inverters together, it will actually lead to some some random information for me, right? So it may lead to that these 5 inverters are really performing, are underperforming, but that is really not the case. So filtering and analyzing this data is really properly is really important. And I mean, all of us know that data is very, very important for us. I mean, data is the new oil that we say. But if the data is not proper, then it's essentially garbage, because you're not able to use the data for any kind of analysis, and it is giving you wrong insights. And this inconsistency is something which is which needs to be addressed very properly, and with a proactive mindset, and with a, like, as the topic suggests, inadequate O&M. So to make it more adequate, it is important that the attention is paid on this activity, because what happens with most of the developers that we have seen, a lot of them, is that once the SCADA is set up, then people do not pay attention to how the quality of the data and all. So because this thing is redundant, I mean it is sitting, it is giving me data, now I'm analyzing it, but it's very important to see what is going on behind it as well. Okay, so for the last basically trailing 12 months, so daily data for that trailing 12 months, and in our analysis, what we found that when we were filtering, because of the issues in the data and abnormal values here and there. Once we filtered the data, we found that only out of 365, only 187 days of data can be analyzed to understand the performance. The rest remaining days had abnormalities, had issues because of wrong reporting in one inverter and another inverter reporting fine. So I cannot compare the two inverters in that case. So you see, there is a red bar graph and there is a green bar graph, and this is for a particular plant. The red is for inverter generation, total inverter level generation, and the green is net generation. Now coming out to be less than the net generation of the plant, which is absolutely here. When we again went into the data, what we found was that basically the data recording from inverter is not coming in properly. So if the data is not coming in properly, it is essentially leading to a wrong reporting of numbers, and leading to a lesser PR at inverter level and a higher PR at net generation level. So again, this is because of the loss of data that happens in the SCADA because of either inverter level communication issues, or either overall communication level or data logging issues in the main SCADA or on the cloud as it happens. So these are two things, these are things that we find for pyranometers, for SCADA. So I think few people are raising hands. Is it okay if we take questions at the end, Abhimanyu?
Yeah, it will be taking it in last 15 minutes.
All right. Perfect. Thanks a lot. So I'll continue and then we can take up questions later on. And if anyone wants to discuss or have any questions or wants to bring some ideas, we'll be happy to discuss that. Moving on to the other, big issue, which is soiling. So, soiling is something which all of us know. It is one of the biggest component of biggest known component of plant maintenance since the start of industry. But in our observations, we still find soiling to be an issue. Although all of us, if anyone would read this slide or get to know, if you would see the topic of the slide, that soiling loss, then it's like, okay, I know about it, and so what's new? But the more important point that we are trying to stress here is that the issue still persists and it is still existing. We are still seeing soiling level issues in the plant, and the impact soiling has on various other things also, which I will cover later. This slide, and this is what we find across the various sites. The key things could be around the cleaning frequency, the cleaning methodologies that is being followed, robotic versus versus manual cleaning. So all of these things that we see, and for example, if the methodology of cleaning is not proper, it will lead to improper cleaning of a module or inverter, module, or at a string level, leading to mismatched losses in modules. So those kind of issues are highlighted over here. What can be done to prevent this? We know that there is a soiling loss that is happening. There are certain soiling loss measurement tools that are available. If you don't have that, like for example, if it's a small plant, or if you do not have that soiling measurement tool, you can do it once in a year or that kind right or not. So other thing that we find here is that the TDS levels of the TDS level could lead to scaling of on modules. So there is a scaling deposition that we see on modules, which can be cleaned with the IPA solution that are available again, available in the market generally. But if you find it at the right time, if it is in your O&M practices, then it is very, if the O&M processes are structured very well, then you are more likely to find it. Otherwise, then they will skip, and they will come up later on when when you see really low performance. Another thing is mopping from the edges. So what happens is that in general cleaning, a lot of times, because the modules are slant, the bottom edge is not cleaned properly, or is not mopped till the end. So the mop starts from the top and it comes to the bottom, but it doesn't really cover the bottommost part of it. And because if you see these days we have larger and larger modules, so cells have come to almost the edge. Now if there is soil deposition happening, so it will keep increasing and will start shadowing the cells as well. So this kind of again, this is a more of a cleaning methodology issue, which can be addressed properly by training the manpower properly, doing some sample level observations at the plant. Then again, discoloration might also occur on the modules. So because of the quality of water, if it is hard water, there can be discoloration on the modules that happens, which can lead to again, which is basically scaling, or leading to loss of transparency of of the glass, and leading to lesser generation. So this is another things. One of the last point is a little bit, one might think that how can one do that, but this still happens in few sites, that cleaning improperly with brush and and not with microfibers, that can lead to scratches on modules, again leading to issues. So here at the bottom we have shown three sites. So Madhya Pradesh, Karnataka and Maharashtra, where where we were looking at estimated versus actual. So estimated was, you could always see that difference that is there. And how this is important, this learning is important, I'm going a little bit out of operation and maintenance perspective, is that now that if one has those learnings, it can be incorporated properly in financial models. So, or in not in financial model, that is kind of the end result of all the analysis, but as an input test for EYA estimation, energy yield estimations. So the soiling loss estimations that people do for various sites during PV, we have seen a lot of times, we have seen that those estimations are quite wrong. So they consider very, a lot of best case scenario is there. So that can be properly incorporated over there, because later on what happens is that then once there is a PV, once there is a as-built PV that is there, then when the plant is under operation and the plant is not performing well, then they ask us to come in that as-built PV is this, but the performance is this. And then you get to find that the soiling assumption was assumed to be 1% in the PV during the construction phase, during the design engineering phase, but actually on site it is 1.5 or 2%. So that is kind of a big learning that we have made over time. Another thing that we have seen is, this is not a comparison of robotic versus manual cleaning in no way, but it is very important to understand where the benefit of robotic cleaning can be utilized and where the manual cleaning can be beneficial. So because dry cleaning has become more and more prominent. At one of the sites, we had seen that the image on the right that you see, this is the image taken, you could see dust on the hand. And this image was taken 10 minutes after robotic cleaning, right, in some plant. Essentially, what we found was that in this particular plant, the robotic cleaning, because the dust levels are very, very high, so robotic cleaning is able, robots are able to clean to a certain level, but still there is a certain level of dust which is deposited here. So it shows basically that the cleaning is not happening properly, and if the through the robotic through the robots. And here, now that because already the robots are installed, one may have to include some manual cleaning cycles as well. So yeah, so that choice has to be made very intelligently. And I think now we have good number of robotic cleaning systems across India. I think one can ask for data from those robotic cleaning machine robot suppliers as well, to understand like the on-site data, to understand what is the actual impact. And this is really, I mean, this was really surprising for us, because they were expecting lesser soiling, and in fact they were seeing much more than what it used to be in manual cleaning. So that is another big observation, that choosing the right robots. And now if the robots are installed, then employing the right strategy to clean the modules on a periodic basis. Here if you see, the average soiling cycle, during average soiling cycle of 3 cycles per month, 3% of soiling used to, average soiling was 3%. And as per their estimation, they had estimated about 1.5% soiling in the system. Yeah, so now they have to do cleaning manually on a 7-day basis to actually achieve that 1.5% figure. So this is another thing. Again, with respect to soiling, this is another observation that we have made. So as I mean, as the industry grew, we learned a lot of things. And so earlier the cleaning cycles used to be uniform across the year, but then I mean, we got more intelligent, and the cleaning cycles were not, now they are not uniform, now they are skewed. So during non-rainy months the cleaning cycles may be higher, during rainy months, all right. So yeah, like I was saying, that this is for the end of the month of May, and the observation was that they were not cleaning the modules because the rains are going to come, but you never improvement in plant performance. And if you do wet cleaning, there could be during rains, but then there is no sufficient rain that happens. Like the rain happens, there's a very slight drizzling that may happen, and then the modules are not partially, like they have clean areas. Again, there could be hotspot level issues. If not hotspot, overall the generation is basically lesser. So we have now, I mean, we have also now started to caution everyone to, to monitor this area, which could be useful. So now people do it. Lack of proactive testing, especially I would say for larger plants, and in soiling, which I missed, which I wanted to share with everyone, that that are that are there. So rooftop of soiling, because the industry or some industrial area, which can lead to a lot of soiling level issues. If I mean, there are solutions available in the market, but I feel that there is still, I mean, developers, asset managers, everyone is frustrated with this, with rooftop level soiling issues. So there is definitely a lot of opportunity over there. I mean, a lot of developers ask us to, to take up their plans to do O&M for soiling level issues for rooftop plants. So because, I mean, everyone is facing issues, and the budget, because the budgets are very less, the cleaning cycles cannot be higher, right? So that kind of leads to the end issue. So what I would share with everyone is that if you are doing rooftop plants, do consider the fact that the soiling will be higher, and you should also consider higher budgets at the start of the plant life itself, during the inception and the discussion stage itself. This is with respect to testing. So there are various testing that is done for the plant of various components, like string level IV measurements, thermal imaging, EL testing, inverter measurements, THD tests. total harmonic distortion, PR analysis. So if you do these testing proactively, so there are very few people that we see, now, I mean, of course, now with big developers, especially, they do it, but still what I would say is that you can do these basic level of testing on maybe on an annual or once in 2 years, something like that, to understand what is the health of the plant or the various components. Not just like module and all of us know that modules are tested properly, I mean, you would focus, but there are a lot of those other components like inverter or thermography of other components. So that to get it from 90 to 100%, all these things become very important. I mean, now the fight is to get to how to get to that top. People have achieved a lot of high performance. The discussion is on how to get to that 99.99 percentile level, and to do that, these kind of tests become really important. So till very recently, you would one might consider it as a good to have solution, but now it has become a must have solution. So because the competition is so high that one has to deploy all of these kind of things. So that is with respect to proactive testing. And if you have done it on a regular basis, essentially what it would do is it would lead to, for you, it will help you in benchmarking the plant much more better. So let's say if you're testing modules, if you're doing imaging of modules on site, it will help you in better understanding of where the problem happened. So year 1 it was like this, year 2, 3, 4, 5, and then year 6 something happened, and once you did the image, you found out, okay, fine, the problem happened between year 5 to year 6, and then you try to find the root cause analysis. Otherwise, I mean, then trying to find a problem and pinpointing the issue becomes a really, I mean, that becomes a really big issue with everyone. Another, like few pointers that I had written, toward just just now, was with respect to non-standardized testing of modules. See, and the understanding of IV testing and element, like there is a huge gap in terms of understanding of what does a IV testing mean on site, using a handled IV tracer, and what it's what are the uncertainties in it. So that education is really important. So do ensure that your teams are, and you are trained on understanding those numbers. Doing it before, I mean, understanding it beforehand and then doing it on site will give you much more better results or understanding of the plant. Another thing that happens is that, for example, I mean, IV testing is done on the site. You may do lesser number of tests, but ensure that you do it in the right manner. So for example, if there is cloud fluctuation, that essentially if there is weather fluctuation and there is cloudy weather, even if the radiation is above 800, one should not be doing the IV testing, because it will lead to wrong results. Because IV testers are supposed to, I mean, as per IC guidelines, you're supposed to measure in clear sky only. So a lot of times people, in order to do IV testing, do more number of IV testing and finish the work like a regular maintenance practice quickly, they do it in any kind of weather. But it is very important to ensure that you do it in the right way to get the right results. Otherwise, your results will be very erratic. So that becomes really important to understand. Similarly in EL imaging, if you're doing it properly, you would get the right image. The focus would be proper to help you understand where the exact issue is. Then, with respect to thin film modules, we have seen that because they are glass to glass modules, sometimes there are a lot of cracks that might come in the modules, and because of those cracks, the mismatch between modules in a string becomes high. So because of that, there is extra loss that happens. So what one can do is, one can take the modules, like those cracked modules, and create a separate block of that to ensure that there is minimum mismatch loss that happens. So that is one of the things that we see with respect to thin film modules. Although now, I mean, there are lesser number of thin film modules, thin film plants that are there. I mean, the percentage is very, very small now, but it is something that can be done. Then the lack of skilled manpower, so which is another important issue that is there, that have your people trained and ensure that they are right for the job. Like someone might be good for A, but I mean, for inverter level understanding or AC side, it may not be good for DC, or vice versa. So it's very important that we have the right, I mean, as an industry, it's really, really important that we have the right people, because it can really help us in identifying problems at a very, very initial level itself. So yeah, so this brings me to the end of the session from my side, and this is more more of case studies. These are more of case studies that we have seen on site. These are really actual things that are happening on site, and we wanted to share that with everyone. So we can we can now, Abhimanyu, how do you like to go ahead with respect to questions and discussions? Atul, would you like to add something over here? Anything if you want to add? Go ahead, Abhimanyu.
Yeah, Avish, thanks for the wonderful presentation. For everyone, like I would request, if you have any questions from this presentation, kindly post it in the chat box. We'll be taking it on one-on-one basis. So Ayush, you can read them in the chat box.